In an organization, there is a need of cost optimization for running EC2 instances or Amazon RDS. We want to stop the running server when not in use. Let's say after office hours. We can do it manually if number of servers are less. But if we have hundreds of servers, this task would become tiring. Here comes the role of AWS Instance Scheduler. With the help of AWS Instance Scheduler, we can manage the running state of EC2 instance or the Amazon RDS. Hello, welcome to Concepts of Cloud. In this video, we will see how to set up AWS Instance Scheduler. Before we go ahead and set up our instance scheduler, let us have a quick look at its architecture. We set up AWS Instance Scheduler with the help of CloudFormation template. This AWS CloudFormation template sets up Amazon CloudWatch event at the customer defined interval, meaning we define an interval at which this CloudWatch event will be triggered. This event invokes the instance scheduler AWS Lambda function. During configuration, the user defines the AWS regions, accounts, as well as custom tag that instance scheduler on AWS will use to associate the schedule with applicable Amazon EC2 and Amazon RDS instances. These values are stored in Amazon DynamoDB and the Lambda function retrieves them each time when it runs it. Now, let us go to our browser and create our first instance scheduler stack. Now, I am in my browser. Here I will search with AWS Instance Scheduler. The first link which we are getting from AWS, we will click on it. This is the architecture diagram which we had discussed just now. I will paste this link in description also. Here we have option launch in AWS console. Click on it. Since I have already logged in as my user, now we are using AWS template, so we will select this template is ready. If you have custom template, you can use your own with user create a template in designer or use a sample template. But for this demo, we will go with this option. Click on next. Since we are creating a stack, so let us put some name also. I put name as CFStack01. Now, instance scheduler tag name. Here it is schedule. If you want to change it, you can change it, or you can leave it as it is. But make sure you keep a note of this, because in future while tagging our instances which we want to control through AWS Instance Scheduler, we will be using this tag name only. Now services is to schedule. In this demo, we will go with EC2 option only, but here we can see we have option to select RDS also. Scheduling is enabled, we will go with yes. If you want to control EC2 instances or RDS in different region, you need to mention here all the region names with comma. In this demo, we will control instances which are in this account and in this current region only, so we can keep it as blank. Time zone would be UTC. You want to change it, you can change it. Cross account roles. If you have some other account also for which you want to control instances, you can put that account ARN number here. As we discussed while discussing architecture diagram, we will be defining a frequency at which CloudWatch alert will be sent. So we will select 1 minute here. If you have more number of servers, you need to increase the size, but for this demo 128 GB is sufficient. Rest of the options we will go with default only for this demo. Click on next. Since CloudWatch formation will be creating multiple resources like Lambda function, DynamoDB, so all those resources will be tagged with this name only. Let us put some name CF01. Okay. Click on next. Click on create stack. Oh, sorry, I forgot to acknowledge this. Click on create stack. Now we can see stack creation is in progress. What this stack will do? This will create a DynamoDB table, create a Lambda function, create a CloudWatch alert also. Let us wait until this stack formation completes. Meanwhile, we can go to our EC2 console. So here I have one instances which is already in running state and one is in stopped state. Let us start this instance also, or let it be for this demo purpose. This is good actually. We have one running instance, one stopped instance. Now we can refresh this. As I told earlier, it will create a DynamoDB table also. So to check it, let us go to DynamoDB console. Click on tables. Till now there is no table because stack formation is still in progress. It will create a Lambda function also. Let us go to Lambda console also. Sorry, I opened a new window. Let us go to Lambda console. So here we don't have any Lambda function right now. We don't have any tables either. Let us wait some time. Okay, so we can see stack formation is complete now. Now let us go to DynamoDB console and see whether any table is there or not. Yes, we can see 3 tables created. Let's go to Dynamo. Let us go to Lambda console also. And functions would be there. Yes, one function is there. In DynamoDB table, we have one table called config table, one maintenance window table, and one state table. Click on config table and explore table items. This is the config part. All the values we have entered here is coming from that cloud formation stack only. It is advised not to change any of the value here. Otherwise, there will be a conflict between that cloud formation stack and this table. So here we can see type as config, default time as UTC, regions is US East 1 because we did not fill any region that time, so it is North Virginia only. Tag name is schedule, which I told you to note it down because we will be using to schedule our instance. Other options we have are schedule and period. Different type of schedules are there and different periods are there. Now, before we discuss this schedule and period, let us go to our EC2 management console. We have one running instance. Select this instance and add a tag. Tag name should be schedule, SC. Now we want this server to be in stopped state because that server was running. So we have one schedule called stopped. Let us copy that, paste it here, save it. I will tell you what is happening in background. So this server was in stopped state. As soon as I added this tag schedule, you can see this came into in running state now. Similarly, I will add stopped tag in this server. Now see, this server is shutting down now. So what happened? When we added any tag running or stopped, that AWS CloudWatch alert triggered and it went to DynamoDB table. In DynamoDB table, when it saw schedule is running, that function turned on the server and bring it up in running state. Same happened with stopped state server also. So you might be thinking that how we can schedule these servers. So we have other schedule also. We can see Seattle office hour, UK office hour. Let's say if we would have added this schedule as Seattle office hours, so that time when CloudWatch alert would be triggered, that lambda function will go to this schedule as Seattle office hour, and here it will see that period is being used in office hours. Again that function will go to period called office hours, and here it will see that beginning time is 9 and end time is 5 p.m. Means if the server is in running state between this time, then it is okay. If it is in stopped state, it will bring up that server. Same thing happens if server is in running state after 5 p.m. or before 9 a.m. That lambda function will turn that server down because office hour is defined as 9 to 17 only. This is how we can use our AWS Instance Scheduler to schedule the servers. We have other schedule also called weekend, working days, or we can add our custom items also. But for this demo, we will not be creating any custom period or schedule. So this is how we can leverage AWS Instance Scheduler and optimize our cost. This was all about this video. We'll see you in another video. Till then, happy learning.